I study the interaction between sunlight and the Earth's surface, particularly the Arctic ice surface. In the spring time, the Arctic sea ice is covered with snow. Not a lot of snow, but enough snow to make it really bright white. So we know that snow has a very high reflectivity or high albedo. But in the summer, things change. In the Arctic summer, the sun is up 24 hours a day, at least in the high Arctic. And this puts a lot of sunlight onto the surface, and it warms it. And the snow starts to melt. And so when the snow starts to melt, there's a lot of liquid water on the surface. And some of this liquid water runs off the sides of the ice floes, and a very little bit of it drains down through the ice, but most of it starts to puddle on the surface of the ice. Melt ponds lower the reflectivity. They're dark. They're detrimental to the longevity of sea ice. They're kind of like skylights, so they let a lot of sunlight through the upper layer of the ice, and that sunlight can get down into the ice cover and into the ocean and provide a lot of heat for melting at the base of the ice. In order to kind of begin to wrap our heads around understanding how much sunlight is actually getting into the ice and is available for melting ice and heating the ocean, we really want to have some idea of the surface area that's covered by melt ponds. The surface temperatures are increasing faster in the Arctic than any place else on the planet. And sometimes it's a little sad to me that it's so remote, because it's not something that everybody has firsthand experience with. It's not a wasteland. It's a stunningly beautiful place. It's a very essential part of the planet's heat balance. And so it's really essential that we take care of it, not just because we think it's a beautiful place and not just because we love polar bears, but because it's really important to the Earth's climate.